Thanks.
All right. Quick audio visual check. Everything okay? Slides okay? Sound okay?
Crystal clear.
All right, awesome. All right, so I'm really excited about this session. Thank you all for joining. What's the goal of this session, right? Everyone's time's valuable. And I'm excited about this session because the goal is to have better conversations with developers and specifically technical people. I know that back when I was on sales, almost all of the presentations that I had that were technical, it was just sort of like at the end of it, I didn't really feel like I understood stuff and I didn't understand how it applied to my job. So I really do think that this session is going to help with your conversations with developers, and it will enable y'all to have more effective conversations. So how am I going to do that? The most important thing is learning to speak their language with confidence. So it's just sort of like, if I got someone and I'm in like a hardware store and I start talking about like efficiency and like value and stuff, then that's not going to resonate as much as like if someone's super technical and I'm like, oh man, did you see like this new thing that came out? It's, 3 millimeters instead of 2, and that allows you to get like more whatever out of like your pipes or something like that. So if you can learn to speak their language, then I think that that's the key to having fruitful developer conversations. We'll talk about why that's the case. Other things I will talk about is life as a developer. I was one for half a decade, so I'll share some more stories. There are many. And I'll talk about their tools and workflow. So before I jump in, I just want to say, feel free to interrupt me, feel free to ask me questions, feel free to just make this conversation your own. And if there's a lot of stuff that you've already heard before, then let me know too, and we'll skip to something that's a little bit more fun. All right, so before we talk about developers, it's really important to understand why developers exist in the first place. And ultimately, like, if you just think about GitLab, we have sales and marketing. Their entire job is to sell stuff, right? And bring revenue for the business. We are in revenue marketing. What developers do is they create the thing that companies sell. That's ultimately what they're doing. And sometimes developers don't know that, but that's their goal, right? That's their functional organization. So what do? For the most part, they create applications. Not all of them create applications, but the most of them do. And the reason why businesses care about their applications is because applications are either revenue driving themselves or it's some sort of background tool that ends up being revenue driving. So something like their backend system like Salesforce. Many different types of applications, things like Netflix, web applications, Facebook, Amazon is a web application. You have applications for your phone, you have tools, and then you have games and things like that. And so one of the things I always say is like, imagine if you and your family, you decide to pivot your career and you want to buy like a store. And so you take out a business loan, $300,000, you're mentally like invested into this store for the next like 5, 10, maybe 20 years of your life, right? So you think about everything, and even the small details, they matter. So in terms of like making my business successful, if I'm a traditional brick and mortar store, then I think about small things like where's the store located out of? What's the color scheme that I'm going to use? What's my target population? How can I make something colorful to basically like be appealing to my target population? So what do y'all see in this storefront? Like what sort of target population do you think this is targeting?
Nostalgic people.
That's good. What do you think
British
about like
people.
kids? British people.
Families.
Why do you say that?
British people. Families or books or British people.
I've never been over there, but I learned something new. What about like what type of, do you think that this appeals to like families or like single guys, or like what sort of population do you think the store is targeting?
Moms.
Yeah, exactly. And like especially moms with children, right? So you can just imagine like a mom with 2 kids walking by and the kids are like, hey, I want to go inside here. There's stuffed animals, this is colorful. And then all of a sudden you get a sale, right? So they think about all this stuff. In the same way for any sort of digital business like Amazon hires all of these PhD psychologists, sociologists, anthropologists, and they study human behavior and how to make their experience like as addicting and interactive as possible. And if you think about it, if my website is a more fun experience than yours, then over a 3-year time horizon, I'm going to have significant advantages over other people. So literally what Amazon does is they do sociological experiments on like, all right, so what are the different types of people in the United States? Well, you have different groups, right? And they'll figure out how they can appeal to each group. And that's a little bit different for each segment. And especially as you think about like, as your e-business scales out internationally, then how you make something interactive and fun for someone in Europe is going to be different than someone in the United States. So that's the reason why they invest so much into these psychological studies and things like that. So how do you stand out in like a digital business? There's 4 main ways. One is that if my application or business, our website does something that yours doesn't. So imagine like Lyft and Uber, right? If one like has some new option that like is going to reduce my cost 20% because I can like share a car with like a bunch of other people or something like that, then, and the other one doesn't offer that option, then I could steal their market share, right? In terms of speed, this is something that matters a lot. It's something that we don't think about, but it really is an arms race. And a lot of times in digital businesses, it's a winners take all market. It's not like, you know, in New York City, you could have like 40, 50 different hardware stores because the population is so large. Usually what happens is one digital business wins and then they get the entire market. So if you're in a digital business, you're constantly thinking about what your competitors are doing. This is the reason why we invest so much on investigating things like GitHub and things like that. All right, so features, right? So 15 years ago, Amazon offers books. They're moderately successful. 10 years ago, you can get a lot of things on there. You can get like household items, you can get cleaning supplies. And just think about what they've done in the last 3 years, right? So in terms of handcraft goods, they own Etsy. You get groceries with Whole Foods, and they're making a ton of money off of this with coronavirus. In terms of entertainment, they own, they have Amazon Prime Video, right? And there's now television series that are only exclusive to Prime Video. You can get contractors and electricians and stuff through Amazon, and they own the most popular gaming platform in the world right now in Twitch. And so Amazon has increased their revenue 400 or 500% in the last half a decade. And part of how they've been able to do this is by increasing their service offering. And all of this takes engineers to build stuff out. This is why they have so many engineers and some of the best engineers in the world. In terms of speed, this is something that a lot of people don't think about, but I'm just going to let the data do the talking, right? So Pinterest is some web platform. You can put images on here, but they found that they increased signups, which you can just think about like acquiring new customers, right? They increased signups by 15% after they reduced their wait times by 40%. So engineering investment reduced wait times. Now they have 15% more pipeline growth year after year. So how much does that matter over a 3-year time period? Well, that makes 50% difference, right? So 15 times 3. So it's a big difference. British Broadcasting Corporation, just a news site. They make all their revenue pretty much off of the ads that you see when you go to their site. They found that they lost 10% of users for every additional second their site took to load. So literally the difference between a site loading between 1 and 2 seconds means that I lose 10% of my customer base. And when I make all of my revenue off of advertisements, then that's 10% of my revenue, right? Google found that 53% of mobile website visits were abandoned if a site took longer than 3 seconds to load. So over here on the bottom, just bringing things home, right? So these are the annual financials for Amazon.com. 2015, they had $107 billion in revenue, bring that all the way up to 2020, they're north of 300. And so what I'm really trying to point out here is like, there's a lot of minute things that we can do, and increasing signups by 15%, not losing 10% of users. But what I'm just trying to point out is that if I make some of these engineering investments, then I can tweak my business 5-10%, and 5-10% for Amazon is $30 billion for 10%, right? So that's the reason why all of these companies have so many engineers, performance engineers, developers, testers, QA, things like that, is because ultimately this helps them get competitive advantage for their digital business. All right, so now that we talked about the why of what developers are here to do, we're gonna start talking a little bit about some of their tools and workflows. I'm gonna try to demystify some of this stuff. If there's anything that I can help to clarify, just let me know, and feel free to ask me whatever questions you want. So let's just talk about programming languages. All of your applications like Netflix, Amazon, YouTube, they're just literally written in programming languages. And so let me just share my screen real quick. Over here is GitLab. GitLab fundamentally is a bunch of text files. And every single application you will ever use, like Google Documents, whatever, if you were to take a look at what these actually are at a fundamental level, is that they're just running text files. And so this is GitLab code. If you ran all of these text files, which is just machine instructions, then GitLab runs. And all of like this text over here, it is just a programming language. So let's just start talking about this real quick. Applications are written in programming languages. Programming languages, fundamentally, what they do is they just tell machines to do things. So it could be, you know, turn on Zoom. It could be like, you know, shoot missiles at like some test site or something like that. And there's a lot of different programming languages. Fundamentally, the way to think about this is that like in human interaction, there's a lot of different languages in general, like French, Spanish, Italian, whatever. And fundamentally, you just use it to communicate. And the difference with a programming language is that fundamentally they're doing the exact same thing, which is to just tell machines to do stuff, but their syntax is different. Just like if I wanted to communicate, hey, I'm going home, I'd say that differently in like Spanish and English. So it's just different rules for telling machines to do certain things. Sometimes programming languages are used for different purposes in technology. If I'm like doing big data stuff, I'm using Python. If I'm building out a website, I'm probably using JavaScript. So that's something to know about programming languages. Over here, you can see the popularity of programming languages. And as a developer, I really care about this because it takes around 5 to 10 years for me to really get great at a programming language. And so if I'm investing all of this time into a language that's declining in use, that decreases my market value, right? So it just literally makes no sense for me to be programming in something if that language is going away. Programmers are really cognizant of you know, these trends because this is their ability to ultimately make bread, right? Over here is Python, and we can sort of figure out somewhat of what this is doing, right? So this is some sort of command line thing. You can do like -L, which is an option, --graph, which is an option, so on and so forth. Over here is Ruby code. This is actually GitLab. And so over here, this is something called a runner. Well, that's a GitLab runner, right? And some of the things that it's doing is, you know, it's giving options, right? So things like access level and stuff like that. So I just want to bring some of this home, and I'm going to demo programming languages for y'all real quick. So let me know if you can see my screen. It should just be my desktop and some black box on the top left. All right, great. So I made this little like code thing over here, and now pay attention to what's happening here now that I'm executing it. So someone let me know what's going on, like what's happening to my screen.
Looks like you're just making a bunch of folders on your home screen.
Yeah, exactly. And so this is just machine instruction, right? If you're gonna take a look at the top left, I made some script thing, and all it's doing is creating folders, right? At the end, it deletes the folders. So you kind of have to ask yourself the question of like, who cares, right? I can just right click and then go to a new folder and name it, and it doesn't really matter, right? But now you have to think about like, what about if instead of just creating folders, like I'm pushing out updates to computers, right? So it's like, I may have to update 30,000 machines. So if I log into one, update it, log out, and then I just go down the line, 30,000 machines, that takes me like half a year. But with programming, like I can push out something to 30,000 machines by my command line. And that's automation is like one of the fundamental reasons why programming exists in the first place. Share my screen again real quick. All right, so that language that I just shown was Bash. I could have done the exact same thing in Python and Ruby and anything else, because fundamentally they're doing the exact same thing. It's just different syntax. All engineers are doing all day is they're writing little scripts that do stuff. So it's like I wrote that script that created folders that took me like 30 seconds to make. When I was a developer, I was writing scripts that made websites and things like that. And fundamentally, the text files just describe like how a website should run. Fundamentally, all developers do is make these text files, and that's how they get paid, which is kind of interesting to think about. All right, so let's talk a little bit more about like the specific things that they do. This isn't just learning technical stuff for technical stuff's sake. All of these things have to do with either something that GitLab does or something that developers do that matters for them and that GitLab interacts with as part of like our sales motions. So libraries and dependencies, this matters because GitLab manages your libraries and dependencies. So let's talk about what they are, right? They're basically the same thing. That's kind of like that's a little bit unfair, but for all intensive purposes, they are the same thing. And the whole idea with this is like, imagine yourself 25 years ago when computer science was new. So people are making websites for the first time and everything's new and everything's novel, which is really an exciting period of time. So it's like, if you think about the dot-com bubble, part of the reason why it happened is because there's just so much excitement and novelty in everything, right? But fast forward to 2020 and most stuff has, or I want to say most things, but like a huge number of things have already been done like thousands of times. So it's like, if I'm making some button for a website, then there's 30,000 other businesses around the world that are making very similar buttons, right? So it doesn't make any sense for me to reproduce everything. What a library and dependency is it's like, it's a bunch of different code snippets that you can use so that you don't have to reinvent the wheel the entire time. So you have libraries that create buttons, you have libraries that generate random numbers, you have libraries that help you to do statistical things. And the whole idea is, as opposed to just doing everything over and over again, then you can use a library instead and save yourself some time. So the vast majority of programmers, all they do is they specialize in a few popular libraries. In other words, if I understood how this thing called Django works, then I can get a job. And I have a bunch of friends that literally, they just specialize in Django and get paid $100,000 a year doing Django. So it's important to understand how libraries are used. Just like in a car, you have a lot of different components, right? So you have wheels, you have your transmission, you have your engine, you have like the frame, you have like axles and things like that. In software and in applications, you have this thing called a stack. And what a stack is that it's all of your different technical components, how they fit together and what components actually exist. And so I'll give you an example of this. Like in a website, you need a database. Then you need an API probably. You probably need some sort of messaging system. And at the top level, you need like buttons and stuff like that. That's actually going to make the website look good. So all of those individual things is like a dependency or a library in general. Over here, you can see the popularity of different libraries and dependencies. And once again, developers care about this because this is their market value. So like, for instance, I think that when I talk to developers a lot of the time, I ask them about what libraries they use, and then I try to appeal to their ego because this is part of like how they make money. And so it's like, I'll talk, if I can, I'll try to like talk about like the new developments and some of this stuff and just trying to get credibility. And so we can do that with GitLab, right? So it's like, hey, you have GitLab core. Are you interested in learning about what happened in the new version of it or something like that? And that can be a good way to have a conversation. So let me show y'all an example of a dependency real quick. Let me know when y'all can see my screen. It should be the big black thing. Great. So I'm gonna go into Python real quick. And one common thing that's really popular, like if you ever played like poker online or something like that, is that you got to generate chance, right? So there's 52 cards in a deck. That means that when I'm being dealt a card, there's 1 out of 52 of any chance that like I get like an ace of spades or like, you know, a queen of hearts or something. So you got to figure out how to like implement chance. And one way that you can do that is by generating random numbers. So right now there's this library called random that I'm going to use. And if I use this, now that I've called random, I can generate random numbers, right? So over here I got 0.49, over here I got 0.6, over here I got 0.59. And then how like I can make a game is if like, let's just say I'm rolling a dice, right? So between, I'd have 1/6 of these random numbers be like a 1, 1/6 of these random numbers be 2, all the way through 6. And that's how I can simulate like dice being rolled and stuff like that. And I didn't have to write any of this stuff. I'm just using the random library to do this for me. And so this is a really simple example of generating random numbers, but like you can also have libraries that help me create buttons and things like that. And one thing more about dependencies and libraries, GitLab can store them. That's part of the reason, that's part of our sales motion. So as opposed to like, if I'm like actually an engineer that is creating some sort of library, then GitLab can store that. And ultimately that's an example of tool chain consolidation. So I can save money as an enterprise because it's just one less tool, one less thing to maintain. GitLab can do that for you. All right, source control management, fundamentally, all your developers, what they're doing is they're just creating applications, and the applications are just running sets of text files, which is just interesting to think about, is that we pay all these people $50 an hour or whatever to like update text files. And so you need some sort of tool to manage all of these text files. Why is that the case? With an open source project like GitLab, then we have maybe 500 engineers. But on top of that, we have in any given release, like several thousand OSO changes that are coming in from the community, right? So if you have now, let's just say 2,500 different people editing the same set of text files, that becomes really, really, really confusing. So that's fundamentally what GitLab does, is it manages these text files and also runs CI. And we'll talk about what CI is in another Tanuki Tech class. So source control management, this is the tool that stores all the code. The market's consolidated on Git. As you can see in the bottom left, they have on the bottom right, they have almost the entire market share. And one of the things to know about this is that Git's free. And because it's free and open source, what other people do is they take it and then they make like enterprise better versions out of it. And that's fundamentally that's what GitHub does, that's what GitLab does. And other people do that too. So DevOps Azure, they also have Git stuff built into it as well. Yeah, another thing to know about it is Mercurial, Perforce, and CVS. All of this stuff is basically like the market's consolidating on Git. So if you were to go 5 years before, it'd be a lot more even, but everyone's moving to Git because it's like the best way of doing things in general. All right, we got to talk about the release cycle stage. And the way to think about this is that like we have a quarterly system, which means that in the beginning of a quarter, they tell us our goal for the quarter, and then we have to figure out like how to build pipeline and like how to do this and achieve this, right? And so there's also like a cycle like this for software engineering projects. This is a very stressful cycle. And just like how, like one of the things that I hear all the time is like, how can I keep my job fresh? And other things is like, how do I prevent burnout, right? This is actually something that's actually pretty common for engineers themselves, is burnout. And I've definitely been burnt out before as an engineer. So we'll talk about the different stages and what they call the release cycle. And a release cycle is basically just sort of like the next version of GitLab, right? So right now, let's just say we're on GitLab like 13.1. So then we have another month to make GitLab 13.2, right? So there's a couple of stages in general. The first stage is the plan stage. So there's these guys called product managers, and what they do is they figure out what sort of stuff should we do, like what should we build? And there's all sorts of rules that they use to like figure out how to do, which things should get in, which things shouldn't. Then the second thing is that after they figured out what we want, the developers, they get assigned work items, and then now for the next like 2-3 months, their whole job is to like develop this thing. So it could be like some new chart, could be some backend system. After that, you have test or QA people, and what they do is they check the product to make sure that it actually works. And then finally, you have release or engineers, and then they make the next version available. So could be updating all your servers or something like that. All of this cycle is really stressful, and we'll talk about why in a couple of slides. So let's just talk about this from a GitLab perspective. Your product managers are going to come in, they're going to say, what do we want in the next version of GitLab? And then after they figure that out, they're going to create a bunch of issues that correspond to all of these new things. So if we want the next version of GitLab to have like X, Y, and Z, and the reason why is because this is the way the market's going. We think that the engineering investment's going to be the value, the cash value of this is going to be $1 million of our engineering time. And we think that we're going to be able to get like $5 million of revenue out of it, additional revenue out of it, right? So they do a bunch of financial math to figure out what things we should work on. And then after that, they'll create like maybe 50, 100 different issues. And then as an engineer, what happens is an engineer gets assigned this issue, right? So when I was an engineer, they would create a ticket and then put my name on it. And then that's what I'm responsible for the next 3 months. Over here, people are collaborating on the issues. What's the best way to do this? So have you thought about doing it this way? And then, okay, well, what about this? And then someone from another team could say, oh, I did something similar a while ago, and you should think about doing it this way, so on and so forth. And they basically collaborate. And once all the collaboration's done, the developer goes and disappears somewhere and works on something, and they hand in their work in what they call a merge request. So this is someone's answer for this issue. And here's like the changes that he wants to make. Fundamentally, once again, all applications are just text files. So he wants to add in this green text, take out this red text, replace it with this green text, and so on and so forth. And you have to basically like prove that your answer is the best, right? Because especially in like an open source project like GitLab, then you have people that are submitting like junk and people who are submitting things that are half-baked. So you have to like prove like, they may not know me, right? I could be some random guy in like some country that like doesn't know the GitLab development team. So I would have to like prove like, you should accept my change to your product because of X, Y, and Z. So over here, you can see like some of the comments, right? So it's like, I believe that this is the best way to do things because of this. And I've taken these other approaches. And then so people can question you on it. Like, hey, have you thought about doing this? Hey, I also worked on this before. And, there's a better way of implementing this change, so on and so forth. So you have to basically prove it. One of the really great things about GitLab is because so many different teams can use it, you can just have better collaboration in general. So if you're using something like I'd say like GitHub traditionally is just developers. And the big problem with that is that your collaboration, if you were using GitHub, is just going to be developers. But one of the great things about GitLab is that everyone can use it. So I also have the test perspective. I also have the DevOps perspective, and so on and so forth. And ultimately, the better collaboration means that I come up with better ideas and approaches in general. So we walk through a bunch of this. So after the merge request is merged, then I basically am done as a developer. And so now there's these test or QA engineers that all they do is they bang on the product and make sure that it works. If I invented a new button, then they're going to click on the button and make sure that it takes me to the right screen. If I like made some new backend system, they might turn it on and off 5,000 times and to see if it still works. That's part of what test engineers do. And then finally, when we think that everything's validated, then the release engineers, they create the next version of the product. GitLab can do all of this stuff. So as opposed to most teams, they have like one product management tool, one developer SCM tool, one like test tool, and one bunch of release tools. You can just use GitLab for everything, which is really, really, really helpful. We can just merge request. We talk about this is where collaboration happens, and that's basically the value of GitLab is that our merge request collaboration is going to be better because different people are using this. All right, I think that this is something that's really, really important for us to understand. So this was a big meta study that was done in 2017, and it had to do with software projects, right? So the whole idea is we want to have like a grasp on the industry. So what are some of the industry trends that we're seeing regarding IT? They found that 14% of IT projects fail, but out of these failures, that was only a small percentage of the failures, right? They found that out of the projects that didn't fail, 31% didn't meet their goals, 43% exceeded their initial budgets, and 49% of projects were late. So literally, out of IT projects and the customers that we talk to, they are late 50% of the time. And I just want to like talk a little bit about some stories about just like one of the things that for my own developer experience, right, is that I think that being an engineer is really, really stressful. And we'll talk about why, right? So you're constantly being asked to do things that don't exist, and your teams are consistently failing. So like I was working, when I was an engineer, I actually worked on one of the best top like products that Red Hat had to sell. So it was like the top dog product, right? Our hiring was great. A lot of people really wanted to be on this team because it was really famous. And we hired talent. So the people that we hired, they had many, many years of experience. It wasn't just some sort of like guy that we got out of college. But even though we hired all this talent, we were still late, I'd say like 60 to 70% of the time. As a, how this actually plays out in practice is that usually what ends up happening is because the teams aren't communicating with each other, your developers are late a huge number of the time. And if there's like a set amount of time that we've allocated for this project, because the developers are late often, then like the test engineers were supposed to have 4 weeks to get to validate everything. But because the developers were late, now we may only have 2 weeks to get everything in. And so all of a sudden I have to work my weekends. I have to work until like 9 p.m. a bunch of days in a row. And what ends up happening is the test engineers don't do as good of a job as they could, which means that we release software that is bad and has defects in them. So it's really, really common that software gets released that like doesn't work completely. And the engineering teams actually know that it doesn't work. If you think about like updating your iPhone, then a lot of times like when you update your iPhone, like something stops working or it's weird. A lot of times the engineers actually know that what they're releasing doesn't work and they release it anyway because they have no ability to influence like the release date because of some sort of business decision. So and then what ends up happening is once again, like these projects are late 50% of the time, which just creates a lot of stress. If you imagine like this release cycle might take 3 months. And so every 3 months I have to work late, like pull 60-hour weeks for several weeks in a row. So burnout's pretty high among certain engineering teams. All right, I know that I've been jumping around a lot. Can I help clarify anything that we've talked about so far?
Yeah, I threw one question up in the chat earlier because when we talk about libraries and dependencies, I mean, is that similar to say a framework, or is there like a big difference between those two?
Yes, that's a really great question. A library and a dependency and a framework, they're different. I'm kind of conflating them together as just some sort of generalized tool that people use to do a certain purpose and not reinvent the wheel the entire time. To actually like dive in a little bit more about the nuances of what these are, a framework is something that could be like a bunch of libraries that people use to like create buttons and charts and like all of your graphical elements for a website. So libraries are very extensive. Your entire like user interface could be one library. A dependency or a framework, sorry. So all of what I just said is about a framework. Framework could be many different libraries combined together. A dependency in a library is generally more specific to like one thing, but I'll just give you an example of, I think I use Django over here. Django is really a framework, and it includes many different libraries and dependencies. But the whole idea is that Django is responsible for your entire user interface. Underneath the hood of Django, there's a bunch of different tool things that when combined together makes Django work. And then so those are like libraries and dependencies. That's a great question.
Thank you.
One quick question I had just on like the verbiage. I hear a lot of other like people using Bitbucket or GitHub calling it a pull request. Do all other SCM solutions call it a pull request and we're the only ones that call it a merge request, or are there others that also call it merge requests or something else?
That is a really great question. Our primary competitor is GitHub, and they call it merge requests, or they call it pull requests, I'm sorry. So in general, we mean merge requests, and most other people think about it as a pull request. We like to be special a lot of the time. Sometimes it's being special for being special's sake, and sometimes it's because we have really good reasons for making things different. Yeah, so to answer the question, the industry uses pull request. Pull request and merge request are basically the same thing.
Gotcha, cool. And another thing just on like the delays, you mentioned that stat of how many times like delays happen in kind of the software development life cycle. You said most of the time it's the developers being late. Like, is that also, like, what are the other reasons that they could be late? Just like planning was too short a time frame type of thing, or just each one ran longer than they expected?
Yeah, so that's a really great question, and it has to do with why certain engineering organizations are better than others. Honestly, the number one reason why an engineering organization is better than another one is because of the culture that is in that organization. So certain organizations you can just think are really, really big, right? And because they're really big, you may have a development team in India, and then your test team is in China, and then things are sprawled out. And then what ends up happening a lot of the time is that people don't communicate. And when people don't communicate between your groups, then there's misses all of the time. So the 1A and 1B of why organizations aren't that efficient, 1A is that is just like a cultural problem. So lack of communication, lack of people working together, lack of accountability and transparency. 1B is so 1A is culture, 1B is lack of communication. I'd say that in your typical engineering organization, around at least 20% of all of your engineering time is completely useless because people didn't communicate. When I was an engineer, that happened all the time. Is that like, I'd be designing this thing, it depended on someone else's work. The person that like was actually building the thing that I depended on changed it. And then so he didn't communicate it with me. And then so I spent the next 3 days like building something that ended up not being used. That happens all the time in engineering organizations. So so it comes down to communication and culture for why engineering organizations don't deliver.
Chris, when you say many of the projects are behind schedule or they're pushed out with bugs, what are some of the consequences for failures from, let's say, an engineering perspective? Are engineering staff members fired? Are they reprimanded if they push out something that's not legit?
Yeah, it has to do with your organization. A good engineering organization will hold people accountable, but a lot of times there's honestly huge problems in engineering organizations simply because I'll just put it this way. So like I played basketball, right? Basketball is about 100 years old, which means that we have a lot of really great best practices for basketball. And like, if you're a coach, you can look at a team for like 5 minutes and understand how like mature people are, right? The problem with software engineering is that software engineering has only really existed for 30 years. And during that 30-year period of time, it has literally changed. Like it changes dramatically every 2 years. And so the roles and best practices for software engineering are completely different. And best practices only exist after we gather data, right? So for instance, like the public cloud is something that's only really existed for 4 to 5 years, but it has dramatically changed best practices for software engineering. Yeah, I hope I am answering your question, but
no, you are. Yeah, like just holding engineers accountable, and basically things are always changing. So definitely.
yeah. And then another thing is that managers, a lot of time, they don't know what their engineers are doing, because like, if you just think about it, like, let's just say I've been a manager for 10 years, which means that I fundamentally, within that 10-year period of time, my skill set's obsolete in 2 years, which means that I don't understand like what my engineers are doing on a day-to-day basis. And then so it can be really, really hard to actually have like accountability in your organization because of that. There's a lot of different reasons. I hope
Thank
that
you.
helped.
No, it does. Yeah.
Cool. So now that we talked about developers, we got to talk about the hardware side of things. You need a computer to run all of these text files, right? And these computers are called servers. So over here, each of these rectangular units is a server. There's around 60 servers in this picture. All of like a vertical row of these servers is what we call a rack. And back in the day, what you do is, if I were a small business, I'd buy 5 of these. This might cost me $20,000. And then I put my website on it. And then that's how like my website runs fundamentally. And these servers live in these buildings called data centers. Data centers are distributed all across the country. The main thing for a data center is energy cost. Around 2% of all of the energy in the United States of America. So it's like literally all of our energy consumption, 2% of it goes into servers in the United States. So there's more energy that goes into these machines than there is for all of the street lights and traffic lights in our entire country, which is kind of really crazy to think about. Over here, you can see a map of some of the data centers that we know about in the United States. And one of the things that I really want to point out to is like speed. So we talked about how I want to have competitive advantages over my customers. If my e-commerce business is not the fastest, then I'm at a disadvantage. Over a 5-year time period, I may lose 20% market share, right? Compound that with the fact that most digital businesses and markets are a winner takes all. Like, so for instance, in New York City, you can have, there's enough market there for probably like 50 to 100 hardware stores. In an electronic business, if Amazon wins, that pushes out like basically everyone else, right? Amazon's just like the big winner, right? So they really think about things like performance over here. And so if I live in Seattle and I'm going to a website that the servers are in Austin, Texas, it'll take about 1 second for me to go talk to this computer server over here. That takes some time to get a response. Takes about 1 second for that response to go back. And so all of a sudden, this is 2.5 seconds, which is too slow, right? So I'm at a competitive disadvantage if that's how my servers are distributed. And so what people will do is, Amazon's smart. They know that they got to go win the performance battle. They are also going after the features battle, right? And they got to have competitive advantage. So what they do is they have servers in Seattle, in Portland, in San Francisco, all across the country. And then they have all of these performance optimization engineers where they basically say, okay, you live over here, our closest Amazon data center is here, therefore you should go talk to this Amazon data center. And so they actually do, all these engineers are paid like $75 an hour. It's a really expensive thing, but the investment is worth it for a digital business, because that's how I have competitive advantage over my competitors, is just by being the most fastest and reliable service. So even think about Netflix, right? So if Netflix isn't super stable and it's laggy from time to time, well, that's going to be more market share for Prime Video. Are you all familiar with cloud computing? Because if we are, I'm going to somewhat gloss over this slide. All right, does anyone want to hear about cloud computing? All right, good. Okay, so cloud computing is a new paradigm in technology that it's transforming how the IT space. Previously, you bought 5 of these. If you're a small business, that costs you $20,000. The big problem is, if I'm scaling up, then I got to buy another one. I have to wait 2 weeks for that to come in the mail. I have to go through procurement. then my engineers bang on it for like a month, and then now all of a sudden, like I have a new web server, and that's really, really slow. That entire process takes me a month and a half, right? So with cloud computing, you can do this way faster, and as opposed to you owning your own hardware, then someone else owns your hardware. So these are the cloud vendors. Amazon was the first in the market, so they have a huge chunk of the market share. Microsoft is number 2, Google is number 3. Just to like put this into reference, GitLab's revenue, our annual revenue right now is around like $130 million. Microsoft closed one deal that was about 100 times that about a year ago with the U.S. Department of Defense. So like one deal being 100 out of like, you know, the 40,000 that they have in a year, just that one deal was over 100x our entire annual revenue. So it's a huge market. And part of the reason why cloud computing is so successful is that they make it easy for people to get new hardware, right? So this is Amazon Cloud, and over here, if I want to get like a new server, then look at how easy this is to get a new server. All I have to do is go to instances, launch an instance, and what type of instance. So I can get, you know, Amazon Linux, I can get Red Hat Linux. I used to work at Red Hat, so let's pick this. It asks for all the hardware, right? So how many CPUs do I want? How much memory do I want? All of this stuff costs different money. So in general, like a medium-sized, you know, server is going to be around like 12 cents per hour. But like a big one, if I were doing big data stuff, would be like around 40 cents per hour. So let's just pick this one. Configure instance details. I want 100 of them, right? And keep in mind, like the old way of doing things is that like I buy some physical server that has to go through procurement. Then my engineers have to spend like a month banging on it before it's ready for doing anything. I can get 500 of these servers if I just by going and typing this in. So I'm not going to do that, but I'll put in 2. Add storage, right? What kind of storage do I want? And this is next to this firewall stuff. So it's like, what ports do I want open? This is fine. This is just SSH. And if I click review and launch, then in 2 minutes, I will have 2 servers that are ready for me to use. And so this is literally just like it's a huge paradigm shift for how IT works, simply because you can do things way faster and you can have consumption-based pricing. Another real reason why the cloud is a big deal is, let's just say that I'm a small business, right? So I got my A round funding, $2 million in funding, and I don't know if I'm gonna exist in 3 years, because my entire like goal is to try to get like, you know, $200,000 in revenue so I can get my B round, right? So what I don't want to do is invest $40,000 in capital expenses. I'd much rather pay an operations cost of like, you know, $100 a month, because if the business doesn't work, I don't want that sunk cost, right? I want to just pay monthly as opposed to that. So this is important because GitLab is really, really good for the cloud. We were designed with the cloud in mind. And so GitLab can scale up and down in the cloud, saving people money. And also it's really good for what a lot of our customers do is like, you know, after you have GitLab, all of your tests run, your CI runs, and then at the end of it, you want to push out and your next version of your website or something like that. And we're really good at like getting you cloud environments so that like we can push out and release the next version of your software. All right, so I'm going to talk about virtualization and containers real quick. I'm going to try to explain this in like the best possible way. If this is not clear, then just interrupt me and let me know. But this is important because our customers are using virtual machines and containers. And one of our fundamental value drivers is that we're really good for containers. So we need to understand what containers are, why businesses have them, so that we can ask really great questions for these customers and help to educate them on our value offering regarding this stuff. So what's virtualization? Virtualization is the ability to split a machine into a bunch of machines. So if you've ever had like a Super Nintendo emulator or something, then I have like a virtual Super Nintendo running on like my PC. And so like, why does this matter? So previously, and one thing important to note is that like in general in engineering, you only want one application for each of your servers. This is just like some engineering best best practice. And if I try to get too many applications on one server, then you just run into problems. That's just how it happens. One reason why, in general, why this would be bad is that, like, let's just say that I have 20 applications that are running on this server. They're important, like Salesforce and all this other stuff is running on it, right? My email system's running on it. And then I update one of these applications and it requires a restart. Well, if I restart this server, now it brings down 20 of my applications, right? As opposed to just one. So that's just one example, but there's a bunch of reasons why you want one application per server. So here's the problem though. The problem is, what if one of my applications only requires 2% of like the memory and stuff of this server? So it's some, like my printer surface, really, really, really lightweight. Well, that means that 98% of this server is completely wasted from a resource point of view, right? So it's just not an efficient way of doing things. So it'd be much better if I can somehow compartmentalize the server into a bunch of different like operating spaces. So that's fundamentally what virtualization does. I'm going to show you what this looks like real quick. And okay, can you all see my desktop right now? If someone said something like, okay, great. So over here, I'm going to turn on this thing called VirtualBox. And once again, this is just a Mac, right? But as you can see over here, I have this Red Hat Linux server that I'm going to now turn on inside my Mac. And so I'm going to hit the start button here. And then all of a sudden now VirtualBox is running and now my Linux server is starting to boot up, right? So I'm not going to click on this because sometimes I get problems with my computer, but it's just turning on right now. And as you can see, like there's different resources that I gave this virtual server. So it has memory, 1024. It's got like virtualized hard drives and stuff like that. And this is like the login screen. It's hard to see right now, but the whole idea is that like, even though this is Mac OS, I could have 10 of these virtual machines running on my Mac. 3 of them could be Linux, 1 could be Windows. And the idea of me having to waste all of the rest of my server for one app, I can now put one app in each of these VMs and I can have 10 of these VMs running on my Mac. So it's just a way more efficient way of running, like of utilizing my hardware, right? And let me go back to my slides. Sorry, there's like a lot of windows right now. All right, can you all see my slides again? All right, great, thanks. Okay, so that's virtual machines. If you get something from the public cloud, you're getting fundamentally a virtual machine. And if it's on-prem, they're probably using VMware. All right, we gotta talk about containers now. Containers are a really, really, really big deal. And it's like, just like how every 3 to 5 years, there's something that dramatically shifts how IT works. Containers are one of these things. And it is dramatically gonna shift how IT works. And one of the things that's really important to know is just like sort of explaining what this is. Is that like, so virtualization was a new paradigm in computing, right? So in the beginning, you basically got all these physical servers and installed stuff on them. And then the ability to split them into virtual machines, it fundamentally shifted how things worked. The way to think about containers is that it is the next version of virtualization that's just better. So all of the benefits that you get from having a virtual machine, you get that with containers as well. They work a little bit differently, but from a business perspective, the reason why people care about them is that they're way faster and way more resource efficient. So the idea is that like in my Mac, if I could get 10 VMs, I might be able to get like 50 containers. And ultimately I can do more workloads and run more web applications and stuff using containers then. So let's just say that like I'm a digital business. My operation expenses from my servers are, let's just say $1 million a year. If I wanted to have an equivalent workload between virtual machines and containers, I could probably save like maybe 50% of my operating expenses. I'm sort of making that number up, so don't quote me on that, but it is a substantial difference in terms of its efficiency. So that being said, the entire IT market is going towards containers. It's validated. It's not some sort of experimental thing. It's something that every single like IT director, they either have these containers or they want containers in their environment because the value is already substantiated by industry. So we got to talk about what Docker and Kubernetes is. So what Docker is if I want containers running on one machine, so like my Mac, then I have Docker. But, you know, like if I'm Netflix or if I'm Amazon, then I need more than one machine, right? I need 100,000, 500,000 servers all running like my web application. So if you want like a bunch of machines running containers, then what I really need is I need some sort of like overhead layer that's going to manage the entire process. So this sort of management layer is going to determine how many containers are on each machine, how many machines are in my cluster, what happens if I turn a cluster like a server off, like those containers should theoretically migrate to another machine so that my web service doesn't stop, right? And so that management layer is what we call Kubernetes. Kubernetes is a management layer for if you want like 50,000, 100,000 machines running containers all in your same environment. So let me just show you how this stuff works. Let me know when y'all can see my desktop again. All right, great. So over here is my terminal. It's not what I was trying to do. And so I want to run some containers on my server. So I'm going to run Docker, right? So what I'm going to do is Docker start a WordPress server. And now that this is running, so theoretically, I should have a WordPress server running. So by me hitting enter and waiting for 5 seconds, I already have a server up and running this web application, which is just WordPress, right? So I can click continue, so on and so forth. But this is just an example of how containers could be used. And the takeaway point is that they are the next generation of virtual machine, which is faster and more efficient. And because of this, every business wants this. And this is really great for GitLab because 30% of our entire product is surrounding containers and Kubernetes. And it's something that everyone wants to use and utilize in their environment. So we're really greatly positioned for this right now. And just to summarize, if I want containers running on one machine, I use Docker. If I want 50,000 machines running containers, I need some sort of management layer. That's what Kubernetes is. Kubernetes is validated. Everyone wants to use it. It's the hot stuff in our industry. All right, so last topic is APIs. So here's GitLab, right? And something that says, this is for our handbook, is www.gitlab.com, project ID 7764, and then says source for about.gitlab.com. This repo project is the public-facing marketing website for GitLab, including improvements to docs in the handbook, right? And I want to pay attention to this web address right now. So gitlab.com/gitlab-com/www.gitlab.com. If I go over here, however, to gitlab.com/API/v4 project 7764, and this 7764 is over here, right? So this is the endpoint that corresponds to what we were talking about earlier. Then you can see that there's this gigantic blob of text. The important thing is that everything that is on this endpoint is also here somewhere. So ID 7764, description source for HTTPS about.gitlab.com, description this repo project is the public-facing marketing website for GitLab, including improvements to the handbook, right? And so every single major web service, Facebook, Google Maps, GitLab, they have corresponding API endpoints to anything that the website shows. Craigslist has an API, Twitter has an API, so on and so forth. Now let's talk about why does this matter, right? So do y'all use Yelp at all? All right. Yeah, so like this is a restaurant that's in Raleigh. And as I scroll down, one of the things that you see over here is, for some reason, even though I'm on Yelp, there's Google Maps that's in Yelp somehow. And so immediately I start thinking, one, how does this work from an engineering perspective? And two, why would Google, which is like another company, allow this other business to like use their stuff? Like they have to have some business agreement, right? Otherwise you're just like copying my service somehow and I better get a cut of it. Well, that's the reason, is that they actually get a cut of it. Over here, this is the pricing for Google Maps. As you can see, if I want 1,000 static maps, then it's $2 per 1,000 requests. If I want a dynamic map, so it's like, you know, you can zoom in and zoom out and whatever, then it's $7 per 1,000 requests. So if I went back to Yelp, I just sort of like reloaded this page 1,000 times, then this literally would cost them $7. So it's just kind of crazy to think about, but how all of this works behind the scenes is through APIs. And the reason why is because Yelp can go over here, go to the restaurant name, right? Get this data, copy and paste this graphical image, and then display it here, right? But if they're using an API, then they can do that exact same thing, and it's going to be way, way faster if you're using an API. It basically comes down to speed. And so let's just sort of zoom out a little bit. Every single major web application or e-commerce business, they have an API. And fundamentally, why I want an API if I have one of these services is because if people are using my data, I can charge them money. That's what Google does, right? And the other thing is this increases the visibility of the e-commerce platform or service that I've built. Every time someone sees Google Maps on some other website that's not Google Maps, it just increases the visibility of the tool that I built out. So now more people are using Google Maps, and now I get more people's data and I get more money by advertisements and things like that, right? So that's why I want to have an API in general. All right, so let's just bring everything home. Technology is just like, when I was a developer for 5 years, right? And so it's almost like you have all these projects, you're late 60% of the time, that every time I'm late, the project's late, I already know going into it that I'm gonna have to pull 60-hour weeks, right? And that's like, that's the rule, that's not the exception. And so burnout's really high. I've definitely been burnt out as an engineer before. And just because, like, if you just imagine if you're late 50% of the time, then what happens? People are stressed out, which means that everyone's blaming each other, right? So it can be like a really stressful environment. And why is this the case? Well, part of it is that technology changes are just happening so fast. And so, like, I have a friend who's a nurse practitioner, and I watched her go through graduate school, and she spent like, 200 hours learning neurology, 200 hours learning the cardiovascular system, so on and so forth, studied her butt off for 2 years, but now her skill set is basically going to set her up for life, right? Because it's not like she has to learn like new modern medicine practices every once in a while, but like when you're an engineer, if you have a web service that is best in class, it is going to be completely obsolete in about 1.5 to 2 years. Literally, like it will be completely need re-architecting in like 1.5 to 2 years. So you're never really get there just because technology is going so quickly. If I had a really great application before the public cloud came out, once the public cloud came out, then it's no longer like a best in class application. My competitors are starting to implement this public cloud stuff, And if I don't do it, they're gonna save 30% of their marginal cost on me. And if they do that for a long enough period of time, they're gonna have a business advantage over me, right? So it's a struggle because technology just changes so quickly. What are the specific things that people care about? So in terms of features, right? So we have a team here that literally every time Microsoft DevOps or GitHub pushes out some new thing, then we immediately need to know about it. We need to like update all of our competitive sales intelligence and stuff on it and everything, right? So features matters a lot. If GitHub can do certain things way better than us, then we got to figure out like how to combat that, because over a 5-year time horizon, if they have significant features over us, then we might lose our market share, right? In terms of user experience, it happens, it just changes all the time. What's popular in one season's gonna be like not cool in the next couple of seasons, right? In terms of security, this is a really big one. I'll just put it this way: if Twitter can get hacked for, like the Twitter hack that happened like about I think it was like a month and a half ago, and then they got like a bunch of Bitcoin from that. Imagine if they hacked like Donald Trump's Twitter account, right? Or like, and if they can hack Twitter, then pretty much every single company is vulnerable. And the reason why is just because it is incredibly, incredibly difficult to fully secure any sort of web service. Even if you hired all these guys from MIT and Stanford and you basically had them audit your entire application, the fact that your application is just changing so quickly means that there's always going to be vulnerabilities, right? So security is a huge problem. Most technology companies feel behind. Imagine if like you're literally not delivering on your projects 50% of the time. You're thinking about like, that's just your mindset, right? It's just sort of like like being on a sports team that's like losing a lot. So there's a lot of pressure from that as well. Where does GitLab fit into this? I wouldn't have come to GitLab if I didn't believe in the product. I really do think that it is a product that if our customers were able to leverage it completely, it would help them to systematically have competitive advantages over other people simply because they could be more efficient as an organization. So I was a developer for half a decade. If we had GitLab, it would totally have helped us a lot. If we fully utilized some of its capabilities and features, we would be maybe at least like 20% more efficient. And if you think about it, like our engineering budget was like maybe $1 million a year. So like to become 20% more efficient, that value is like $200,000 for just investing in one tool, right? So how do we do this? Become more efficient, deliver better products faster, reduce security risk. Kind of leaving the session on cliffhanger, but like if you take the Tanuki Tech 210 and 211, we'll talk about exactly diving into how we do this and the questions that we can ask our customers to help uncover needs and basically explain why this is the case. All right, so just talking about homework real quick. So how y'all get like credit for these sessions is by filling out these Google Docs. Only spend around 30 minutes on this. I'm not looking for people to spend a ton of time on it, but the whole reason why I actually pulled up the wrong one, why it's important to go through some of these questions is because I really want y'all to have the exact terminology down for when you're talking to like a DevOps lead or like a lead engineer. And the reason why is because they have very, very specific terms that they use. And then if we use them a little bit wrong, then it's real easy to lose credibility. So I want to help you make sure that like you're having great conversations with these people. All of these questions have to do with technology and they are questions that could be used in a call. So yeah, just what do y'all think about getting this in, committing to getting this in by or on Friday of this week? So that'd be 4 days out. Is that fair for 30 minutes of your time? All right, great. So that's it for this session. Is there anything that I can do to like clarify anything we've talked about? I know that we've jumped around and talked about many different topics. Otherwise, feel free to, thanks for your time, and I'll see you in the next session. But I'm happy to answer any questions if anyone has any.
Yeah, Chris, when you said you've gotten burnt out in the past, can you describe those feelings so I can better empathize with some of the developers out there?
That's a really great question. I would say that there was only one time in which I was really, really, really burnt out. And honestly, the emotions that I had was just sort of like, I literally could not do my job anymore because like I couldn't concentrate. And during that period of time, so it's like, to just sort of like put the emotions of like what this is like is just, I was specifically a test engineer, and when the developers are pushing their stuff in, they're late all the time, which means that specifically me, I need to go put in a 60-hour week because of something that like I have no control over, right? It was honestly really frustrating. And it was also just sort of like, if you imagine just doing that every single release, we have releases every 4 months. They're not, I'm salaried, so they're not paying me any more money, right? Like, so it just gets really, really frustrating. And especially because it's like completely 100% avoidable. So it's like literally, if people collaborated more, then we could have avoided like this entire situation in the first place. Burnout's really common among engineers. It's not as common as sales. Sales has 30% turnover year after year. So it's not that high, but it is high in general across the industry.
Got it. Thanks for adding color to that. Yeah.
Maybe it like gets into it for like future sections, but like for like the open APIs with GitLab, like we talk to a lot of people that are curious about like their integrations, and that's kind of like the fallback is we have open APIs on things that aren't very native in GitLab. Like, I guess like how do we know like what they can get from, you know, one tool into GitLab? Like, because we have a customer we're talking to, or a potential customer right now that's like evaluating all these different security solutions and bringing them into GitLab. Like, how does that all work, I guess?
Yeah, that's a really great question. So I think that the answer is that GitLab literally can integrate with everything because of our API. And is that a concession, or is that like something that's like a strength of us? People are used to, because like APIs are how applications talk to each other, by us saying you can integrate with anything through our API, that is literally what everyone else is doing. So it's not a concession, right? It's the truthful answer, is that you can, if it's Jenkins, you can integrate GitHub, literally whatever sort of security thing that you want, you can hook it into GitLab. So obviously we don't want to be like everyone else. We want to have competitive advantages over other people. And so we want to build on top of that and make it easier, right? So like so how we do this is like by making it even better than an API integration. So when we talk about our Terraform integration, we make it even easier than building out something from like an API integration standpoint. And I know that was kind of a convoluted answer. The short summary answer is that we can integrate with everything through our API. That is not a concession. That is just standard industry practice. As a matter of fact, our API is very, very good. There's like different tiers of like APIs. Some of them are really hard to work with, and our API is very, very good. So we can credibly just say we have a very full, mature, robust API that you can integrate any of your security stuff or Jenkins or whatever you want into GitLab.
Cool, thanks.
Chris, how do you access the homework? Is that in the drive?
I'll share it with y'all.
Okay, cool. Thanks.
So at the end of this call, I'll share it with y'all.
Appreciate it.
Cool. Well, if there's no additional things I can help out with, then I hope y'all have a really great week, and congratulations, Caleb. I didn't know that you were out on paternity, but that's freaking awesome. And I'll see y'all in a future session.
Yeah. Thanks, man. Good to see y'all again. Don't congratulate me, dude. I didn't do anything. I just sat there like my wife did all the work. I'm useless, dude. So, but awesome, man. I'll see y'all. It's good to see you.
Yeah, thanks so much, Chris. Thanks, everybody.